All right, we're going to do a problem that's going to help us with our first in the homework. First, we're going to revisit something that we've worked on in the past. So we've got a spinner, and a third of the time when we spin this, we're going to land on A. Okay. So, and we want to find the mean and standard deviation of landing on an A. And then we're going to be asked to graph the distribution using a column graph. Okay, so we've already learned that the mean is found by multiplying the sample space times the probability. So we could say that this is, since we're spinning it 5 times, and our probability of getting an A is 1/3. Okay, so this is how we would write this. And so our sample space is 5 because we're spinning it 5 times, and our probability is 1/3. So our our mean is 1.66. So there we go. And then, so if we spin it 5 times, we expect about 1.6 times we're going to be getting the letter A. Now, to figure out the standard deviation, as you know from your formula, it's the square root of the n times p times 1 minus p. So we get 5 times 1/3 times 2/3, and then we get the around 1.1, and take the square root of that, and we get 1.5. So that means our standard deviation is about 1 plus or minus from 1.6. Okay, so if they ask you to graph the distribution using a column graph, what they want you to do is they want you to figure out the probability of getting all the different possibilities. So if you're spinning it 5 times, you're either going to get no A's, 1A, 2 A's, 3 A's, 4 A's, or 5 A's. Now, from this kind of graph, you're highly unlikely of spinning this and 5 times getting an A, right? So that's why the probability of getting an A every single time is very, very low. So the probability of spinning it 5 times and never getting an A is kind of low, but definitely not as low as getting A 5 times. Okay, so how did I get these numbers? And then once you get these numbers, we're going to make a column graph, which is what they've asked you to do. Okay, and it looks like it's more likely to not get an A than to get an A, right? And it makes sense that it would be down here. And the mean is supposed to be 1.67. So between 1 and 2, it makes sense that the peak of this graph would sort of be around here. Now, like I said, how do I get these numbers? Okay, so to get these numbers, we're getting specific probability. And so if I go back to my notes from the other day, so find the probability of exactly getting the letter A twice. So to get it twice, I do second var, and we use PDF, which gets me a specific one, getting it twice. So the first letters are sample space 5. This is our probability, and 2. So, and that number should match the 3.29. That should match what we had here. So now we need to do it for x equals 0, 1, 3, 4, 5. So let me do a couple of them. So how did I get the 1.32? So I'm going to hit enter on. Okay, so second var, I'm going to arrow down until I get to binom PDF, because that gives me a very specific one. I'm going to hit enter, and now we're spinning it 5 times, so I put in 5 first, comma, my probability, which is 1/3, so 1 divided by 3, comma, and then I'm going to put in 0, because we're finding the probability of getting A 0 times after spinning it 5 times, and then I hit enter, and then that's how I get this value. So if I want to find out what's the probability of getting the A once, we can do this process again. Now, to save myself all the trouble of retyping all this in, notice how it says entry above enter. I can do second enter, and it retypes in the whole thing for me. And I can arrow back and then change that 0 to a 1, and then I hit enter, and then I get this value. So second enter to get this entry, and now I'm going to change this value to a 2, and then now I've got that value. So second enter, I'm going to change this value to a 3, and I get this value. Okay, second enter, I'm going to change this 3 to a 4, and I get this value here. And then I do second enter, and I'm going to change this value to a 5, and I get this value here. Okay. Now, if I've done this carefully and properly, I should be able to add all of these up to get 1, because the probability of getting a 0 and anything between that and 5, you're not going to get a 6, right? You're not going to get a negative. You're not going to get a negative 1 times. So anyways, if I do a distribution graph like they've said, you would get something like this. And this is where we're going to go towards when we go to normal distribution. We'll talk about the graphs. So anyways, if your graph is centered right in the middle, that's called a bell-shaped graph, and it would make sense. So the probability of getting an A should be a third, right? And so whenever the probability is less than 50%, your graph is going to be leaning more this direction, so it's positively skewed. So if we said, what is the probability of getting a B, the graph would be leaning more this way, which would be negatively skewed. Okay, and that should help you with the first problem.